All right, hello once again, Algebra 2 people. So this is going to be the second video going over some things with dividing polynomials. I will link to the first video at the end of this one. In that first video, we had just some examples where everything had a zero remainder. Today, we're going to see some remainders. And also a couple of things to kind of just be mindful of and make sure that you notice as you're doing these problems. Okay, so let's go ahead and jump right in here. Again, we should already know the process of long division. So we do 2x minus 3 on the outside and dividing it into this whole thing here. Okay, and again, we should know by now how to do this. So 2x times what would give us 2x to the fourth. So that's, we just need a 1x to the third or x to the third. We multiply by both of these things. And remember, we're always subtracting and always changing signs. So that minus sign is going to distribute, making that a minus and make that a plus. So those guys cancel out. This will be negative 6. And then bring down the 21. Repeat the process, right? So 2x times what would give me negative 6x to the third? That's negative 3x squared. It's plus 9. And again, we are distributing, so that becomes a positive. That becomes a minus. Those guys go away, and we have 12x squared. Bring the 26x down. Repeat, repeat, repeat. 2x times what would be 6x. So again, we got a minus here, you got a plus here. Those guys go away, and we have, let's see, minus 8x again. And then bring the 10 all the way down. So that's minus 4. 2x times minus 4 will give me negative 8. And plus 12. And that becomes a plus, that becomes minus. So in this case, this cancels out. Yesterday, everything canceled out. But in this case, 10 minus 12 is negative 2. So that is my remainder. Okay? So the way we write our final answer, this is still most of the answer, my x to the third minus 3x squared plus 6x minus 4. But if we have a remainder, we basically go back to your third grade, like when you first started dividing. So like if we did something like 3 divided into 70, like way back in the day, you would do like, okay, well, 3 goes into 7 2 times, subtract 6. 3 goes into 10 3 times, subtract 9. We had a remainder of 1. So before we even did decimals, you would just write that as 23 1/3. You took the remainder and just put it over what you divided by, right? And made that a mixed fraction. We do this the exact same way. So whatever your remainder is, it can be positive, it can be negative, it might even have some x's in it, which we're going to see in just a minute. So whatever the remainder is, we're just going to say it's plus, and then remainder here is negative 2 on top over whatever we divided by our divisor. And that's your final answer. Okay, so the only real difference when you have a remainder is you just add that last term just like you did back when you first started dividing numbers. Okay. Now, the last two examples, they have a little bit of a wrinkle to them. Again, the process itself is exactly the same, but I want you to look at this real quick and tell me if, and just say to yourself, because you can't tell me because I'm on a video, but if you think to yourself, is there something kind of different about this one? And what you might see is that it's like it's missing an x squared term. It's got an x to the fourth, x to the third, but then it skips all the way down to x. When you see that happen, my recommendation is to basically make a placeholder. And this is what I mean by that. So this is going to be on the outside. So x squared plus 3x plus 2. And then the inside, 2x to the fourth plus 3x to the third. What I recommend doing is literally making an x squared term, just putting a 0 as the coefficient. And the reason I like doing that is it's going to keep everything lined up. It's going to keep our like terms kind of where it's supposed to be. If you watch some other videos, they may just say like leave a space or whatever. I like literally putting a 0x squared just so it's easier to kind of see what's happening. But once you kind of notice that and put that placeholder, everything else is the same. So start the process again. So x squared into 2x to the fourth would be 2x squared. So we get that matched up, we multiply everything else. So that's a 6x to the third, and that's a 4x squared. But just like always, we are subtracting because that minus sign is distributing. So those guys will cancel out. That's a negative 3, 3 minus 6. And that's a minus 4, 0 minus 4. And we can bring the 5x down. Same thing, x squared times what would give me that negative 3x to the third? That's minus 3x. Negative 3 times 3x is minus 9x squared. Negative 3x times 2. And again, distribute, so that becomes a positive, and that becomes a positive, and that becomes a positive. So it cancels out, and we have negative 4 plus 9 would be 5x squared plus 11x minus 1. Bring this guy all the way down. And then last step, 5x, x squared times what would give me 5x squared, and then we just need the 5. Keep on multiplying, that's 15. 5 times 2 is 10. And again, we're always changing signs. So that cancels out just like always, but we have an x term this time. 11 minus 15 is negative 4x. 1 minus 10 is minus 11. And that's all I can do. Once you get to this last step, if you can multiply x squared to get what you want, then you're just done. So this whole term is our remainder, and that's okay too. And just like we did on that first example, we're going to take this remainder and just put it on top. So minus 4x minus 11 over x squared plus 3x plus 2. When we get into the next unit on rational functions, we'll talk a little bit more about kind of what that means graphically, just on kind of both of those first two examples. But for right now, this is kind of, we just want to make sure we understand the process of long division for polynomials. Okay, so I've got one more example, and I'm going to ask you to pause the video so you can try to do this on your own. And again, notice this time what I'm dividing by has that missing term. So I'm going to start this off at least, but I'm going to let you pause the video in a second. Since I'm missing an x term here, I'm going to, again, make a placeholder on the outside just to keep everything lined up and make life a little bit easier when I go through the process. So again, if you want to pause the video, and then I'll start going through the solution here in just 1 second. All right, so 5x squared times what would give me 15x4? That would be a 3x squared. 3 times 0 is obviously 0, but that's where the x cubed comes in, so 0x cubed. Again, just by doing that, you see it kind of keeps everything lined up with your like terms. 3 times 2 is 6, x squared. Subtract, change all the signs. Alpha doesn't really matter because it's 0. So that cancels out. 5 minus 0 is still 5. Negative 19 minus 6 is minus 25. Bring down to 5. Repeat the process. 5x squared times what would give me 5x to the third? All I need is an x. X times 0x is just 0x squared. X times 2. That's a minus, that's a minus, that's a minus. So we got negative 25. 5 minus 2 is 3. Bring the 11 down. And last step, 5x squared times what will give me negative 25x squared. Just need a negative 5. And that's a plus, that's a minus, that's a plus. And again, the sign of 0 doesn't really matter. So I have left over 3x minus 1, negative 11 plus 10. And that is my remainder. I kind of wrote kind of small up here, so I'm just going to write my final answer right below here. It would be 3x squared plus x minus 5 plus 3x minus 1 over 5x squared plus 2. So polynomial long division, keep an eye out for missing terms. If you have a remainder, you're going to write that at the end over your divisor, divided by. There is another way to divide sometimes called synthetic division that we'll do next time. But as always, if you have questions, come in for tutoring, send a message, and until next time, stay safe.